Tonight, when it gets dark, step outside and look up. Count the stars in one small patch of sky. You have done this before, maybe as a child, maybe last summer. The sky felt permanent then. It felt like the one thing that does not change. Now imagine you count again and the number is wrong. One star is missing, not hidden by a cloud, not washed out by city lights, missing. There is a place where it should be, a small dark gap your eye keeps returning to, the way your tongue returns to a missing tooth. You check a star chart on your phone. The chart says the star is there. The sky says it is not. You would tell yourself it is nothing. A satellite passed. Your eyes are tired, and you would probably be right. Stars do not simply switch off. Everything we know about physics says a star cannot vanish quietly. It can explode, it can collapse, it can fade over billions of years, but it cannot just stop. So you go back inside. You forget about it. A week later, an amateur astronomer in another country posts 2 photographs of the same constellation taken 1 year apart. In the first photograph, there are 1,406 stars. In the second, there are 1,404. He asks if anyone can explain it. No one can. Then, an observatory in Chile runs a routine comparison of its sky surveys and finds 16 more. 16 points of light that were there and now are not. No explosions, no final flares, no debris. Each one simply absent, like a word deleted from a sentence. This is where the quiet part ends. Because stars are not decoration. Every human calendar began with them. Every ocean was crossed by them. Every probe we have ever launched finds its way by them. The stars are how we measure time, distance, direction, and our own place in the dark. They are the reference points of everything, and reference points are not supposed to disappear. In the next hour, we are going to take this seriously, step by step. What a star actually is, how stars are allowed to die, and how they are not. What it would mean, physically, for a star to go out ahead of schedule. What you would see from your backyard, what Earth would notice first, and how long we would have to notice it. And at the very end, we will look at one uncomfortable question that sits underneath all of it. If the stars started going out one by one, would it look like an accident? Or would it look like a pattern? Keep that question in mind. Look at the sky one more time before we begin. Count them while you can. In 2009, in a spiral galaxy 22 million light-years away, astronomers were watching a star that should have been unmissable. It was a red supergiant, 25 times the mass of our Sun, the kind of star that ends its life in one of the brightest explosions in nature. And it was behaving strangely. Over a few months, it flared, brightened by a factor of 1,000,000, and then, instead of exploding, it began to dim. By 2015, it was gone. Not dim. Gone. The Hubble Space Telescope looked at the exact spot. Optical light. Gone. A faint whisper of infrared remained, fading, and then, effectively, nothing. The star has a name, or had one, N6946-BH1. It sits, or sat, in a galaxy nicknamed the Fireworks Galaxy because it produces more supernovas than almost any galaxy we know. A place famous for loud deaths delivered a silent one. The leading explanation is called a failed supernova. The theory goes like this. The core collapsed, as expected, but the explosion stalled. Instead of blowing itself apart, the star swallowed its own detonation, and the black hole forming at its center simply ate the rest of the star from the inside. No fireworks, a flicker, and then darkness, and a black hole sitting where a giant used to shine. Understand what that means? Modern astrophysics accepts as a real documented possibility that a massive star can disappear from the sky without a visible explosion. The receipt we talked about, the evidence every death is supposed to leave, can be reduced to almost nothing. Astronomers found this event because they happened to be watching that one star closely. So the obvious next question was uncomfortable. How many stars are we not watching closely? A few years later, a project set out to answer exactly that. It is called VASCO, Vanishing and Appearing Sources During a Century of Observations. The idea is beautifully simple. Take the old photographic plates of the sky, some of them from the 1950s, and compare them, point by point, with modern digital surveys. Look for anything that was there then and is not there now. They expected errors. Dust on the plates, film defects, asteroids photobombing, satellites streaking through frames. They filtered all of that out. And after the filtering, there was a remainder, about 100 points of light present in the old sky, absent in the new one. 100 candidates for something the rulebook says should be almost impossible. Sources of light that existed and then did not, with no recorded explosion, no visible remnant, and no accepted explanation that covers all of them. Most of these will eventually turn out to be something ordinary, a flaring star caught at its brightest. An instrument artifact no one has identified yet. Science is patient with its anomalies, and it should be. But every astronomer who works on this will tell you the same thing. Some of the disappearances are hard. The plates are clean. The object was real. And the sky at that coordinate is now empty. There is a third case worth knowing because it shows how strange a star can act while still existing. In 2015, a star called KIC 846-2852, better known as Tabby's star, was caught dimming in ways no one had ever seen. Not the neat, regular dip of a planet passing in front of it, but chaotic plunges, up to 22% of its light, gone, then back, then gone again. For months, serious institutions had to entertain serious questions about what could block a fifth of a star. The most likely answer today is a cloud of fine dust. But for a while, the most studied star in the galaxy was a star that behaved as if something enormous were passing between it and us. Put these three files side by side, a giant that swallowed its own death and left the sky dark. About 100 candidate sources that appeared in old survey data and were absent from modern surveys. A star that flickered as if occluded by something we never saw. None of this is fiction. All of it is based on published astronomy, and some of it remains unresolved. Now, here is the part that should genuinely unsettle you, and it is not any single case. It is the method. We did not catch these disappearances happening. We caught them afterward, by accident, in the archives. The sky does not send alerts. For all of human history, we have assumed that if something dramatic happened up there, we would see it. A new star, a comet, an explosion, something added to the sky. We were never prepared for the opposite. Something subtracted from it. Our telescopes watch a tiny fraction of the sky on any given night. The rest, the overwhelming majority of those thousands of visible stars and billions of faint ones, is photographed occasionally, checked rarely, and assumed to be permanent. If a star 300 light-years away had quietly gone out in the year 1800, would we know yet? Check the math. Its last light would still be on the road. The answer is no. We would be living under it tonight. Let us run the experiment honestly. Suppose it begins tonight. Somewhere in our own galaxy, a few hundred light-years away, stars start going out, one by one, quietly. What actually changes on Earth, and when? The first answer is unsettling in its own way. Nothing changes. Nothing at all. The light already in transit keeps arriving. The sky above your house tonight would be indistinguishable from the sky last night. Your phone works, planes land, the sun rises. If stars within 500 light-years of us went dark this evening, Earth would learn about each one only when its last light arrived. Years, decades, or centuries later, depending on distance. The news would be on its way the whole time. The first people to notice might not be governments at all. It could be an automated survey or an amateur astronomer comparing the same patch of sky night after night. There are hundreds of thousands of amateur astronomers on Earth, and they are the only large group of humans who still actually look at the sky night after night and compare it to what it was. Somebody photographing a favorite constellation from a backyard would develop the frame and find a hole. They would assume equipment failure. They always do at first. They would check the optics, reshoot, ask a friend across the ocean to confirm. And then a forum thread would appear with a title that sounds harmless, something like, "Has anyone else lost HD 219134?" Then the confirmations arrive and the professional surveys swing over, and this is where it stops being a curiosity. Because the moment one confirmed unexplained disappearance exists, every telescope on Earth has the same new job: finding the others. While astronomy is having its crisis, the practical world would feel the first pinpricks. Satellites keep themselves oriented by photographing stars and matching them against onboard catalogs. Star trackers are built into many spacecraft we fly, from weather satellites to deep space probes. A missing star does not blind them, it creates a mismatch. The tracker sees a sky that no longer agrees with its map, flags an error, switches to backup stars. Engineers would notice a rise in navigation faults, small at first, easy to patch. But the patch itself would be historic. For the first time, humans would be deleting stars from the catalogs, not adding them. And it would not only be our machines. Night-migrating birds steer by the stars. Indigo buntings learn the rotation of the sky around the pole star as chicks and use it as a compass for the rest of their lives. Seals track individual stars at sea. Even the humble dung beetle navigates by the glow of the Milky Way. The natural world has been using the sky as an instrument for 100 million years longer than we have. Erase enough points from that instrument, and something begins to drift in systems that have never failed before. Migration lines bending, arrival dates slipping, and no biologist able to prove why. But the deepest impact would not be technical. It would be psychological, and it would grow with every confirmed loss. Every civilization we know of, without exception, built its sense of order on the sky. Calendars, harvests, gods, navigation, fate. The one shared human experience across every century and every continent is looking up at night and seeing the same fixed pattern our ancestors saw. The sky is our oldest proof that the universe is stable, that the rules hold, that tomorrow resembles today. Now imagine living in the decade when that proof starts developing holes. Imagine explaining to your child that the constellation in their bedtime book is out of date. Imagine the first religious movements built entirely around the gaps. Imagine checking each night the way people now check the news, whether the sky lost anything while you slept. The panic would not come from danger. Nothing is falling on anyone. It would come from something quieter and harder to treat. The suspicion that the background of reality is being edited, and that we do not know by what, and we do not know the order of the list. And there is one more detail, the one an astronomer would whisper last. We would be seeing these disappearances late, each one delayed by its own light travel time. A star 400 light-years away that we lose tonight actually went dark 4 centuries ago, which means the event, whatever it is not happening now. It already happened. We are not watching a crisis unfold. We are watching the paperwork arrive. So the reasonable next question is not about Earth at all. It is about geometry. If the stars are going out in some region of the sky, then that region has a shape. And a shape, plotted over time, has a direction. Before we ask what could do such a thing, we need to feel what it means to lose the stars themselves, not as scenery, as the only map we have ever had. For that, we need to go far from home.